It is given to media with known refractive indices, and question is under what conditions total internal reflection occurs. So let's review what is total internal reflection. So it is given water with refractive index 1.33 and glass with refractive index 1.56, and this dashed line perpendicular to the surface is called normal, and all angles are always measured between ray and normal. And let's consider a ray moving from glass to water, and this angle, it may be I as incident or just theta 1, it's called angle of incidence, and it's called angle of refraction or just refracted angle. Let it be theta 2 or I, it doesn't matter. And to connect angles and refractive indices, we use the Snell's law. Formula is given in a data booklet, and it says that n1 sine of theta 1 is equal to n2 times sine of theta 2. 1 it's one medium, 2 it's another medium. So here it looks like 1.56 sine of theta 1 is equal to 1.33 times sine of theta 2. And what is n? By definition, it's speed of light in vacuum. It's 3 times 10 to the power 8 divided by speed of light in a medium. And for example, for water, it becomes that V is c over 1.33, and it means that speed of light in water is 1.33 times less than in vacuum. And also this Snell's law, this equation can be rewritten in terms of speed of light in medium, so it becomes sine of theta 1 over V1 is equal to sine of theta 2 over V2. And if a ray is moving from water to glass, equation will be absolutely the same, but now this angle is called angle of incidence and is called angle of refraction. And now let's consider situation so that this angle of incidence increases. And you remember that the greater refractive index is, the closer to the normal a ray is. And you can see that here n is greater, so this ray is closer to the normal. This angle is smaller, and this refractive index is smaller, so ray is further away from the normal, or this angle is larger. And if we will increase theta 1 angle of incidence, you can see that it will be like this, and since this angle is always larger, there may be such a situation so that angle of incidence looks like this, and refracted angle is 90 degrees, and it's called critical angle. And if we will continue to increase angle of incidence, there will be only reflected ray and no refracted, and angle of incidence will be equal to angle of reflection. And how to find this critical angle? Quite easy, the same equation. It becomes 1.56 times sine of theta critical is equal to 1.33 sine of 90, which is 1, and sine of theta critical is equal to 1.33 over 1.56. Quite easy to remember. Smaller refractive index divided by larger refractive index, provided that a ray is moving from a medium with larger refractive index to the smaller refractive to the medium with smaller refractive index. And if theta is greater than theta critical in incident angle, total internal reflection takes place. And if a ray is moving from water to glass, you can see that that if you continue, there is some array, and if you continue to increase angle of incidence, since this angle is always larger or this is always smaller, even the angle of incidence is 90, there will be refracted, and when a ray is moving from a medium with smaller to the medium with larger refractive index, total internal reflection cannot occur. Total internal reflection can occur only when a ray is moving from medium with larger refractive index to the medium with smaller. So here, when a ray is moving from what? From glass to water. Glass to water, it's B. And actually, question is when total internal reflection at an interface between them, and may occur only when the light goes from glass to water. The next. A ray of light is directed towards a prism as shown. The prism is made from a material with refractive index 1.5, which of the dashed lines best shows the subsequent path of this ray of light. So it's incident ray. You can see that it moves perpendicular to the surface, so no refraction at this surface. And first of all, we should draw a perpendicular line. It's normal, and this angle is angle of incidence, and n is 1.5 here, 1 for air. For air it's approximately the same as for vacuum. And since we can see the array which is moving from a medium with larger refractive index to the medium with smaller, we should check where the total internal reflection occurs here. And how to do that? Just consider sine of theta critical is smaller refractive index 1 over 1.5 over larger refractive index, and critical angle is approximately 42 degrees. And what is our angle of incidence? It's 30, it's 60, it's again 30, it's normal, it's all perpendicular, so it's 60 degrees. So our angle of incidence is greater than critical angle, so total internal reflection occurs. So it cannot be A, cannot be B. But if it would be angle, for example, 30 degrees, notice that we remember that here refractive index is smaller, so ray should be further away from the normal, so A cannot be at all. If angle would be less than 42, it would be B, but here angle is greater than angle of incidence is greater than 42, so total internal reflection occurs. And we remember that reflected angle is equal to the angle of incidence. And what is this angle? To check whether D is true, you can see it's 30. It's again, you can see it goes without refraction, so it's 90. So it's all is 60, or here it's all is 60, and again it's perpendicular 90 degrees, so it's 30. It's 30, it's 60, and since it is not equal to angle of incidence, it cannot be reflected, and definitely there is only one remaining option. C is correct. And you can see, I want just check, and again, if this angle is smaller than 42, it will be like this. If this angle will be larger than 42, and again, total internal reflection occurs at glass air interface, so the surface. And what about angles, it's 30, it's 60, it's 120, it's again 30, it's again 30, it's because it's 60, this is 60, it's 30, so this angle is 30, and it's less than 42, so no total internal reflection, and there will be refracted into the air. You may consider angles more clearly, but definitely there is only one remaining option, and we can answer quickly. And that's all for this problem, for this question.